and public health. And I'll say that again because the recording's just started. Welcome to our panel on interoperability and public health, an international perspective. And I'm delighted to welcome our four speakers in this panel. So we have Dr. Ed Hammond, who's the Director of the Duke Centre for Health Informatics, Paula Braun from CDC in the United States, Dr. Russell Leftwich from InterSystems, among other places, and Dr. Charles Jaffe, who's the Chief Exec of HR7 International. So we look forward to an excellent panel. Let me just introduce the speakers in a little more detail so that you understand their backgrounds, where they're coming from. So Paula Braun is an entrepreneur in residence at the US CDC, Centre for Disease Control and Prevention. She tracks evolving tech trends and helps to communicate why they matter to public health, and has been recognised as one of the top 50 influencers in the federal government on artificial intelligence. She engages stakeholder groups from across government, academia and industry to help improve public and population health. She's an internationally recognised expert on interoperability and innovation, and she collaborates with colleagues from across CDC to use design thinking and advances in technology to help address real-world health challenges. So we look forward to hearing from Paula in a moment. Ed Hammond, many of us will know over many years, Professor of Informatics at Duke University, has provided vision and leadership in most aspects of health informatics for over 50 years. Engaged in AMIA, ACME, EMEA, HR7 International, ISO TC 215, JIC, PAHO, IADB, and various US government activities over those years. He's Chair Emeritus of HR7, Distinguished Fellow of ACMI. And his current research is in a number of areas: data visualization, realizing interoperability using FHIR, SMART, and CDS hooks, app development, registries, EHRs, human metrics, and data elements. And he leads a think tank effort to define the perfect health system. And I can think of no one better to define it. Charles Jaffe, the Chief Exec of HR7 International, is the organization's global ambassador who fosters relationships with key industry stakeholders. He's been in the healthcare IT industry for 38 years and was previously the Senior Global Strategist for the Digital Health Group at Intel Corporation and the Vice President of Life Sciences, SAIC, and the Director of Medical Informatics at AstraZeneca. Currently, Dr. Jaffe is the visiting scholar at the University of California, San Diego, Department of Biomedical Informatics. He's been the contributing editor for several journals and has published on a range of subjects, including clinical management, informatics deployment, and healthcare policy. And Dr. Russ Leftwich is a senior clinical advisor for interoperability at InterSystems Corporation and adjunct assistant professor of biomedical informatics at Vanderbilt University. He's one of the leads in the development of clinical resources for FHIR and organizer of the HR7 FHIR Clinician Connectathon series. They're called Clinicians on FHIR, which has been run outside HR7 as an educational event. He's co-chair of the HR7 Clinical Interoperability Council, founder and co-chair of the HR7 Learning Health Systems Working Group. He was Chief Medical Informatics Officer for the Tennessee Office of eHealth Initiatives. And before that, he had 2 decades in internal medicine practice and was on the clinical faculty at Vanderbilt University. So very clearly, we have a distinguished and eminent panel with great expertise to hear from tonight on this topic of interoperability and public health. So let me please introduce Dr. Ed Hammond to introduce the session and then take us through the speakers one by one. So Ed, the floor is yours.
Okay, thank you very much. I'm looking forward to opportunity of really sharing with you some of the topics. We picked 4 different focus areas, and that's what the speakers are going to reflect. We will start off with Dr. Jaffe. He will sort of introduce us to HR7 International and to FHIR, and then we'll go through 3 of the other speakers that will give us some glimpse at some component of interoperability, some of it focusing on FHIR, some of it focusing on another topic. And so, Chuck, if you would start us off and tell us a little bit about FHIR.
Thanks, Ed. First of all, it's a real pleasure to share this podium with my colleagues, with Ed Hammond. It's a delight to be invited by IMEA and the Scientific Program Committee. This is an exciting time in healthcare informatics, and in particular in the HL7 fire community. About 10 years ago, I happened upon an exciting piece of information about the role of the API and its influence on virtually every aspect of the way we share information in a broad economy, from transportation and banking to our daily lives and our everyday use of the internet. Open APIs changed the way we shared information. So when Graham Grieve presented the concept around FHIR, establishing a different model for healthcare data exchange with our Fresh Look task force a decade ago, it resonated not only within the HL7 community, but within a very large community of developers around the globe. The clear message that we've received, not only from the technical component of healthcare IT, but also the people on the front lines who are taking care of individuals, doing research, and providing the capabilities that improve our daily lives, recognize that the interoperability of data is really fundamental to the opportunity we have to improve patient outcomes. When we acknowledged the importance of FHIR, not only within HL7, but in a very large global community, we understood that it wasn't simply about change. We need to establish the framework by which FHIR could be used to enable some of the future engagements. Early on in the process, it was not unlike the first rev of any piece of hardware or software. It only enabled exchanging data between health systems or single individuals. But it was with collaboration, not only with Harvard Boston Children's, but with others that began the gradual and accelerating process of sharing data across health systems, amongst health providers and others that needed health data, that enabled clinical decision support for caregivers and others in the healthcare community. And today, CDS Hooks is used in a wide variety of applications to support clinical research and environmental studies. It was with the advent of bulk data on FHIR that enabled the exchange of thousands of clinical records virtually concurrently that provided the necessary data that functioned globally to provide analytics and the impressive advances we've had that affords us. This is a high-level timeline of FHIR in the US, but a lot of the work is paralleled globally. I think in the US, the big change came with the advent of the JASON Task Force report in the fall of 2014 when the US government identified open APIs and subsequently FHIR as the future of interoperability. It was not long after that that ONC, the Office of the National Coordinator, required open APIs in their certification program. In the course of the last 5 years, there's been a broad embrace of only by the agencies, but by the private sector, both in North America and globally. For the next few minutes, I'll talk about that trajectory. I think one exciting moment came when Apple announced that it was embedding the FHIR implementation guide developed by the Argonaut project actually within the operating system of the iPhone and the iPad. It enabled individuals to aggregate health data across multiple health systems, laboratories, and imaging centers. I think for many of us, the next step was the implementation that was largely supported outside of the development process itself. We called it the FHIR Accelerator Program because it really provided a platform for many implementation communities to integrate important use cases, build implementation guides, and develop platforms that enunciated their respective needs. One of the most successful of these was the Da Vinci Project, which connected individual provider organizations and their granular clinical data with the payer community that required information to accelerate prior authorization, to assist in analytics and risk assessment. Codex was, in fact, a research accelerator that crossed multiple platforms. The Codex community addresses cancer care and cancer research, not only in North America, but globally. The last of these that I'd like to mention is the Gravity Project, which focuses on the social determinants of health. Over 1,800 organizations have partnered with the Gravity FHIR Accelerator, not only to identify data elements amongst the broad swath of social determinants, but also to use FHIR to implement those social determinants in decision and patient care logic. Last week, 2 new FHIR accelerators were announced. In fact, Paula Brown will lead the newest public health FHIR accelerator, which has emerged from the CDC after more than 3 years of development. This has broad support within the United States, but also will have implications for other public health agencies worldwide. We expect the FHIR accelerator to go live at the beginning of next year. The second, which is far more technical, is called FAST, FHIR at Scale Task Force. This was a group of individuals from both public and private sectors that developed models and technology for infrastructure in support of the adoption of FHIR. It has been housed within HL7 since its inception about a year and a half ago, and will move over as a FHIR accelerator in Q1 of next year. There will be additional accelerators emerging perhaps early next year or in the year to come. These two are important not only for patient care, but for research. A clinical accelerator with contributions from all aspects of healthcare providers and fundamentally supported by professional societies. In addition, we expect to see a genomics accelerator. There have been a host of organizations that depend upon genomic data for patient care and research, and the ability to integrate this data within the workflow of the clinician is really essential if we're going to have precision medicine at the point of care. This is just a high-level diagram highlighting the impact that FAST will have on FHIR infrastructure. Not only will it provide technical services, including versioning, but also testing, conformance, and certification, which we think are really critical if FHIR is going to have the global impact on interoperability and meet its promise. There are other federal agencies in the United States that have broad reach in the global community. Two of these that come to mind are the National Institutes of Health, which now will require in all of its extramural grant programs, identification of FHIR implementation, and the FDA, which is collaborating with federal regulators around the globe in new product and device approval. I think the future lies in changing our mindset about how we address interoperability. And I believe that FHIR gives this in a way that we hadn't even appreciated a decade ago. The world is beginning to notice. Amongst those are the large cloud providers, which announced publicly that they'll use FHIR APIs to exchange global healthcare data, and more recently have announced that they'll use bulk data on FHIR for the transfer of large data sets to their cloud for cloud and synthetic computing. We're also collaborating with Odyssey, an important partner in the research realm. Since Ed Hammond began this journey some years ago to bring Odyssey into the fold, we've been pressing to have a collaboration that will have meaningful results. Currently, we're developing an implementation guide whereby FHIR resources are integrated within the OMOP data model. And lastly, I couldn't close without a tip of the cap to the Vaccine Credential Initiative, which now has created a technology called the Health Smart Card. This is mine in the left-hand panel on the screen, and it embeds within that QR code information about immunizations and COVID testing. The adoption has accelerated and is now live in 7 US states, including California, Canada, and other countries around the globe, and is supported by a broad community consistent with the WHO requirements that they published in March of this year. So with that, I'd like to say thank you. Turn the mic over to Ed and look forward to the panel discussion moving forward. So Ed?
Yep. Thank you very much, Chuck. Great presentation. If you have questions, put them in the chat. And after the 4 speakers, we'll have an opportunity of responding to some of the questions. Dr. Scott is going to be the person that's going to handle the questions. So just make sure you put them in the thing. Next, we'll switch to the second speaker. Paulo, if you would like to take this to share now and give your presentation.
Great, thanks, Ed. Let me just pull up my slides very quickly. Okay, so today we're going to talk a little bit more and build off of the materials that Chuck Jaffe introduced and really look at it through the lens of public health and how it is that these new emerging cloud-based, API-based standards and approaches to interoperability can help us deal with some of the biggest challenges that we've been facing, not just as a nation, but really as a global community since the beginning of the COVID-19 pandemic. So part of the reason why we're talking about these new approaches to interoperability is not just because they're new, it's because they have momentum. And the reason why they have momentum is not only because it works from a private sector mindset, but also, at least in the United States, there's been a considerable amount of statutory and regulatory incentives that have been passed in recent years, which give us some level of assurance that the types of infrastructure that could be built on top of these APIs really has a pathway to production. It's not based on voluntary adoption of standards, which is the ways that things normally happen, but that there really is, an incentive and to even some extent penalties if these types of APIs, these FHIR-based APIs, are not put into place nationwide. And that presents a big opportunity for us in public health because it's a pretty big paradigm shift in the way that we normally think about aggregating information and getting it to our state, local, territorial, tribal, and even federal health departments. Typically, we've relied on the push model. And the idea would be that the healthcare providers and the data providers would be the ones who would have to extract the information and validate it and route it to multiple endpoints within public health. But what if we were able to have a large amount of the information that we needed, more or less at our fingertips, and all we would have to do is query it? What new opportunities might that open for us? These are the types of questions I've been asking and have been working with others throughout the public health ecosystem in the United States to try to think through. And so today I'll give a little sense of what's coming down the pike, why it matters to public health, and begin to share thoughts on how we can leverage it to our advantage. So that way we can begin to address not just one patient at a time, but really the health of entire communities and entire populations of interest. And so, what is it that the regulators are trying to accomplish? Well, they want to make sure that the information that's captured in electronic health records and other source systems can be accessed and exchanged and used in a manner that's seamless and secure. And so, at least in the United States, there are 3 main ways in which the federal government has been incentivizing it. The first is to make sure that those FHIR APIs go into production on those certified health IT products. And that's a way of making sure that the data that's already been captured during the course of a regular clinical workflow can be made available to authorized users outside of the firewall. And the first type of user that's really being incentivized to be able to access this information without special effort are individuals themselves, making sure that we can have a complete medical record from beginning to end. So that way we can be more informed and hopefully make better health choices that lead to better health outcomes. And then there's also the third leg of this stool is really thinking about all of those data aggregators out there, those health information networks and those health information exchanges. And how is it that we can come to those common paradigms for exchanging information, not just the technological infrastructure, but also the common agreements. And so this notion of having these qualified health information networks that would abide by these common agreements is again, that third leg of the stool. But today we're really going to be focused on those electronic health records because those are the ones that are being incentivized most immediately, and they have a deadline of December of 2022 to make this all happen. And so part of what we're trying to do is make sure that as these type of interoperability paradigms go into play, that public health needs are at the forefront. And particularly since FHIR is so based on community involvement, being really intentional in how we in public health participate in that global FHIR community. So that way we could be at the table side by side and at the helm to make sure that it evolves in a way that can help to protect the health of populations. And the reason why this matters is because COVID has been a real opportunity for us to look at what's been working and what hasn't been working. And while we've made considerable advances, there have been a number of public testimonies that the Office of the National Coordinator has held over the last few months through the HITAC process. And a couple of themes really became clear. Even though we have much better systems in place now than we had even just a few years ago, it's still very difficult for those systems in public health to be able to ingest on the data so that way they can act on it. There's still a number of challenges in making sure that the data can be shared, not just from jurisdiction to jurisdiction, but sometimes even within the same jurisdiction, because the programs under which the data are collected might have different rules and different just syntaxes that make it really challenging to exchange those data. And that puts significant burden on our data providers, and it also puts significant burden on all levels of public health, because we're doing the same sorts of fetchings and translations and validations over and over and over again. It's mostly a very inefficient way of thinking about orchestrating data across a network of networks. And finally, we're challenged to attract and to retain a workforce with the necessary competencies to be able to do the types of integrations that are necessary within public health. And so it's no surprise that in order for us to all be safe, we really need to think of ways in which we can strengthen every link in the chain. And so our data modernization initiative in public health is something that CDC has been leading. And the work that we're talking about here around FHIR really fits in this notion of how can we take the data that need to be provided to public health and make them available for action. So our hypothesis is that these policies and these IT capabilities that are rolling out nationwide, many of which involve the FHIR standard, can help us in public health to be able to access more detailed and more timely information from multiple sources, including but not limited to electronic medical records. And to do it in a way that lowers burden and that delivers greater value, not just on our data providers, but also in public health. And so the way that we're concentrating our investments is to think through three main lines of effort. We're going through the process to making sure that the data that are needed within public health get captured at the source and are made available to public health. And then the second line of effort is looking at all the different ways that data are accessed and exchanged and try to move from point-to-point interfaces that rely on older standards toward ones that are more resilient and more API native, so that way those types of exchanges can happen at scale. And finally, we recognize that technology doesn't exist in a vacuum, and that if we really want to get to the levels of adoption that are needed, it's a matter of addressing the social or cultural dimensions of it, preparing the public health community for real-world testing, aligning the policy levers, aligning the incentives, and using that to help guide our work. So one part of this, the first part of it around making sure the data that we need in public health get captured consistently at the source, is one place where these federal regulations can be really helpful to us. So there's this concept in the United States called the US Core Data Elements for Interoperability. And what you see here are the data elements that have made it into version 2 of US CDI. And so we've been working in CDC and with our state and local, territorial, and tribal partners to be able to say, well, what's not on this list? What might need to be added? And we've been going through the formal process of making those recommendations. And so this year, version 3 of US CDI is one where public health has been selected as a priority area. And so we're optimistic that we'll see a few more public health focused data elements and data classes make their way into US CDI. The other thing that's interesting about US CDI is that it's not just the structured information in an electronic medical record, it also encompasses the clinical notes. And again, so many of the details that we need in public health are captured somewhere in the electronic medical record, but it's not always easy to retrieve that information. And so by working with the bulk FHIR APIs that are rolling out, that gives us one opportunity to be able to run analytics at the point of care, process the data in a way that would be really difficult to do without these types of cloud-based API native technologies, and then using that as an important feed of intelligence to our national and state, local, territorial, and tribal public health partners. And we're just at the very beginning stages of testing these APIs. We had our first Connect-a-thon experience with that last month. And so we're very optimistic that as these capabilities mature, they can improve the information that's needed for public health. So this concept of serving up the data and making it available without special effort is a really important one, because without this type of infrastructure in place, we would still be in a place where we'd have to do almost elaborate acts of kabuki theater to be able to reach into a medical record, to know enough about the underlying model within that system, to be able to get the data out, and then have to know all the nuances of the data to be able to process it effectively. FHIR is not a silver bullet, but it does help to get to a common place. So that way, some of that processing can already be handled for us, and then we're better positioned to be able to hit the ground running. And the other thing that's interesting about US CDI and these standards is that they expand over time. And so it's really critical that we continue to approach this community in a way where we're not just explaining and trying to advocate for our own interests, but doing it in a way where it's a multi-sector alliance, where we can see how the types of needs that we have are similar to the types of needs that other people have, and how can we work together. And so just a few days ago was the deadline for US CDI version 3. As I mentioned, we went ahead and prepared a submission and put it forward to the Office of the National Coordinator for Health IT. And we're optimistic to see what types of data elements and data classes will be included in this next go around. And we're doing all of this work because we want to be able to move away from the current situation wherein we struggle to obtain timely, accurate, and comparable data that's suitable for public health prevention and response, and move into a world where we're able to act more nimbly, where we have more of a common infrastructure in place, where we build capabilities on top of those FHIR APIs and do it in a way that takes the burden off of public health. And so the way we plan on getting there is, again, taking more of an iterative approach, starting with prioritizing our needs, making sure that we're aligning the standards and the policy levers. That's where the FHIR Accelerator for Public Health that Chuck mentioned fits in here, because that gives us an opportunity to be able to bring together the private sector, all levels of government, and the philanthropic sector to be able to say, okay, what critically is needed, and how can we build it as quickly as possible, and how can we test it as rigorously as possible before it becomes widespread. And then building those tools on top of those FHIR APIs And finally, making sure that they are tested rigorously and that there's ongoing streams of funding for ongoing adoption. So looking forward to questions that y'all have. And Ed, thank you so much for inviting me to be part of this exciting panel. And we'll talk soon. Thanks.
Thank you very much, Paula. Russ, we'll move straight to you. If you'll transition.
All right.
I'm encouraging some more questions coming in. I said chat before, it's actually Q&A. There are a couple of questions there, but I hope you will continue to ask some questions. Thank you too. So Russ, over to you.
Thank you, Ed. It's a privilege to be part of this panel, and I'm going to focus for the next 20 minutes on where FHIR is in patient care, in clinical care, and where it's going in the near term. I think where FHIR is going in the long term is so expansive that 20 hours wouldn't be enough to really talk about it. But I'm going to talk about first a couple of the challenges that FHIR helps us to solve, where it's already showing its value. And as you know, as we're 2 decades into the 21st century, there's a exponential expansion of where data comes from. Certainly the hospital EHR system is and will be a critical place where patients' data is found. Primary care providers as well hold data in their systems. Insurers, we know and have known have data, but we haven't been able to interoperate with that data and the clinical data. But as we have come into the 21st century, the number of places that patients, individuals have data continues to expand. Pharmacies, laboratories, imaging centers, researchers, the Internet of Medical Things, patients' own specialists, patients' devices, home care providers, government systems, particularly important in the domain of social determinants of health, and genomic labs, of course, enormous amounts of data, and it's increasingly difficult to bring all this data into the EHR. We need to bring it together somehow, and in the near-term future, we're starting to see that data brought together as aggregated data in health information exchanges. A lot of that depends not on FHIR, but on legacy data standards, and will continue to be the case in the near term. But we can use FHIR to access that data, to make that data interoperable once it's brought together, and to take advantage of the qualities of FHIR that you've heard something about, to access specific pieces of data and make use of it. So why should different stakeholders care about data? Well, if you're a clinician, visibility into data in your own EMR system has been a problem as EHR systems have evolved, and the data was there, but the clinicians could not see their own data in a way that was really useful in their workflows. Clinical decision support likewise has faced a similar challenge from the time it was first developed, that the data in different EHR systems was not consistently available to clinical decision support logic, and that had to be recreated in every EHR system. And FHIR promises to solve this problem. If you're a fiduciary, an insurance carrier in the US and other entities in other countries responsible for paying for healthcare, the ability to exchange with clinical systems is extraordinarily important to improving care, to reaching the goal of value-based care. And as Chuck Jaffe has talked about, the Da Vinci Project has greatly accelerated the use of FHIR to make this exchange of data between the payers of those responsible for paying for healthcare and the clinicians themselves, as well as the patients, making that a reality. There is a more efficient and effective prior authorization, the approval of the payers responsible for healthcare, the approval of special procedures, special treatments, has long been a burden to providers as well as patients, and FHIR promises in the near term to make that prior authorization process that has been cumbersome and slow, a near real-time background process that will improve care and will certainly reduce the burden for providers and patients in receiving effective care. And if you're a patient, real-time access to your medical history and the data is an important component of the FHIR, what FHIR provides. You heard a bit about the Apple iOS and adoption of FHIR, so patients can access their data, and integrating that data with third-party apps, both in the Apple system and with apps interfacing with EHRs, is becoming a reality. It's somewhat nascent at present, as we are just starting to see the implementation of the patient access APIs in the US. And I think it's going to expand rapidly in the near term. Likewise, the Apple iPhone ability to let patients access their data in EHR systems has been widely deployed, but has not had widespread uptake yet. It's available only in the US and the UK at present, but the new Apple Health Kit not only allows access to data, but allows patients to exchange that data with other systems. I think this is going to expand rapidly in the near future. And before I go on and talk about some of the other implementations and applications of FHIR for patient care, I want to talk about a very important problem that FHIR will help to solve. And that is the world of partial interoperability we've lived in over the past few decades since the first appearance of EHRs. And this slide that you see reads from the bottom up. And the important point to begin with is that EHR systems have different ways of storing clinical data. They store that data in a different format, a proprietary format for each EHR, and therefore the exports that they provide of that data, whether they're CDA documents or HL7 version 2 messages, are likewise different from different EHR systems. We have, over the past few decades, developed ways to translate the terminology of the data that's stored in different EHR systems so that we have been able to standardize the terminology or normalize it, as we say. But what we have not accomplished is to represent that data from different EHR systems according to the same data model. So we have consistent terminology, but that's only part of the process of making data usable to different applications outside the EHR. And that has been a big limitation on both information exchange and on decision support services that could be portable across different EHR systems. So the intent of FHIR from its inception, from its first concept, has been to provide full interoperability by not only providing a mechanism to normalize the terminology of the data stored in different EHR systems, but also to provide a way to convert that data into a consistent model, a consistent representation of the structure of the data, and export that to applications outside the EHR in a consistent way, to be able to exchange that data with other systems, with applications, and with decision support, certainly. So that is the promise of FHIR, and one of its most important features that solves a problem that otherwise has limited the use of data in healthcare up to this point. The most visible means of using that capability of FHIR, if you will, you've already heard mentioned as the Smart on FHIR applications, the smart data platform developed at Boston Children's Hospital beginning in about 2010, and about 6 or 7 years ago, combining that data platform with FHIR as an API model led to the development of Smart on FHIR and a considerable number of apps that already exist to leverage the capability of FHIR to represent data from different EHR systems. So one of the most important advantages of FHIR that's already being used is being able for clinicians and patients as well to be able to visualize data in a way that's useful in the workflow of the clinicians. Smart on FHIR is a way to connect with systems using consistent formats for both the data and for security protocols, so that there is a model for applications outside the EHR to access data in the EHR. And I should say that although many of the examples we see demonstrated and referred to are mobile apps, mobile Smart on FHIR apps, this also applies very much to web apps that are able to leverage this same ability of FHIR to represent data in EHR systems for services outside the EHR. This Smart on FHIR capability has formed the foundation of several regulatory requirements in the US in particular, including the US ONC and CMS rules that you've heard referred to earlier today. Where this is going, I think, in the near term, is not only visualizing and using health data that's in a single EMR system, but visualizing the data that comes from multiple EHR systems using the same capability of FHIR to query and represent that data in a consistent way. Many individuals today have data in more than one EHR system, as well as in many other systems, as I demonstrated or displayed on my first slide of the extraordinary increase in the number of places that data comes from. So being able to visualize not just the data in a single EHR system, but to visualize the data from a longitudinal health record, if you will, of an individual, the data assemble from multiple EHRs and other systems for a particular individual, and exposing that data using FHIR allows you to visualize the data. The graphic in this slide shows a fictitious individual who has data that may be in different systems for glucose readings, LDH readings, hemoglobin A1C readings, and that can all be displayed graphically in a useful way for both clinicians and for the patients themselves to understand and act on that data. And this type of accessing data that's aggregated from a longitudinal record assembled from multiple systems can also be used in the US to meet the CMS and ONC requirements. That data, as I said, for the foreseeable future, still will be aggregated using legacy technologies, not necessarily using FHIR, but brought together in a single repository, and then using FHIR to query that data repository, that longitudinal collection of data for individuals, and then make use of the capability of FHIR to represent that data in a consistent way for applications. In addition to the ability of Smart on FHIR apps to represent data from single EHR systems so that it can be used by apps out and services outside that system. This slide depicts a Smart on FHIR app that is already in production that allows you to combine data from an EHR system with data from one of those outside sources, which in this case is a genomics sequencing lab, and combine that with data from a knowledge base, which in this case is a knowledge base of what chemotherapy options work best with a particular tumor mutation, and then provide recommendations to a clinician, to an oncologist, for what treatment is best for an individual patient based on their particular tumor, the mutations that are present in that tumor, and what we know about the best treatment for a tumor with that mutation. But this is all possible because of the ability of FHIR to combine data from different sources and make it computable. Likewise with CDS hooks that's been mentioned earlier. CDS hooks is a part of the FHIR specification that allows EHR systems to trigger a call out to decision support outside the EHR based on events that take place in the EHR, and to return a recommendation to the clinician within their EHR workflow on how to best treat a particular condition or other types of recommendations. CDS hooks is a way of externalizing decision support and leverages the Smart on Fire capability. I believe that the next stage of CDS hooks and decision support will be combining data from different sources to support decisions with decision support that is triggered from within the native EHR within a clinician's workflow, and returning a recommendation that's based on a larger set of data than is available in that particular EHR. All of that possible because of FHIR. I will close with a mention of an article that appeared in the Journal of the American Medical Informatics Association this month, based on a website analysis of apps integrated with US EHR systems. This analysis was done between December 2019 and December 2020, and looked at 5 different galleries of apps available that interface with EHRs. And those 5 galleries are maintained by Allscripts, Athena Health, Cerner, Epic, and the Smart Health IT organization. And this data was analyzed with respect to the category of those apps and the number of apps that were being offered. In December of 2019, there were 600 such apps. In 2020, the number had increased to 734. The percentages of the category of those apps are shown here. And there was some overlap. Some apps did more than one thing. So this adds up to more than 100%, but apps did administrative functions like scheduling and billing. 38% of the apps had clinical purposes. 20% of the apps were for patient engagement, 31% for care management, and 5% for research. When those apps were analyzed with respect to whether they supported FHIR, 19% of them in 2019 supported FHIR, and 22%, a slight increase in 2020. But I think this is a demonstration of the leveling out of apps prior to what I predict will be an acceleration of the number of apps available as the new requirements for FHIR version R4 roll out in the US. So takeaways, FHIR is here to stay. It's evolving, but it's already well accepted. It provides relevant data visibility for both clinicians and patients. And it provides enriched decision-making already based on the data that's in the EHRs, but in the near future, based on a lot larger data set accumulated from the many different data sources that are available. So thank you. With that, I'll close and turn it back to Ed.
Thank you very much, Russ. Can you unshare?
Yes, sir.
Thank you. So you've heard a lot of similarity, even though we're addressing different topics. And what I would like to do is to talk about research, looking at the future. And the first question I've got, talking about the value of interoperability, the question I would ask the people that are listening is, can you imagine a world in which all health systems use the same data elements, collect the same data for the same purposes, and have agreements in place that permit the sharing and access to the data for research while protecting patient privacy. I'm interested as to whether you think this is an absurd question, statement, or whether it's something that we should aspire to obtain. And so part of what I'm going to talk about is how to use interoperability to try to get what we are talking about. But for the last 7 or so years, there is a group that has been making a publication called Mirror Mirror. And this is the latest version of that of 2021. And it really puts to shame the US because we're last in every category except patient care. And yet we spend a lot more money on healthcare than any other country. We're something like 6 times the average. But these are developed countries, and it means that we really need to do something in the US. But even with these numbers, I think that we can apply this even further across the board. So what I want to talk about is a changing clinical research model that I think is occurring. And what's happening now is we're transitioning from paper to digital. And the clinical research is beginning to form a partnership with clinical data, and we're using the same kind of data that's used for patient care. We're seeing an increase in something called pragmatic clinical trials that's using the data collected in the EHR as part of routine care. Now, the value of pragmatic clinical trials is in the real world settings. And so the results can be quickly applied. It's not a research project that we have to figure out how to integrate it into the real world setting. It's part of that. It's easier to recruit. It's easier to get larger numbers of participants because you can get participants that don't have to necessarily come into the healthcare setting to participate in the research itself. And if we are sharing from multiple sites, we are going to have more people involved in this, and it's going to have a lot less cost. So to make these work, we have to have high quality data, and what high quality data means. And we need to be able to transport that data globally, and FHIR serves that purpose. So data itself is the backbone of interoperability. And the things that we're having to do now is share data. We're having to aggregate data across multiple sites. And I think that COVID has really taught us the value of this. COVID is a disease that we knew very little about. We didn't know what the treatments were. We didn't know some of the symptoms, how to diagnose and things of that nature. And so we are having to build larger databases across multiple sites. And with the mobility of patients, we have to track patients across multiple sites. And I think one of the things in the future is going to be extremely important is the fact that with long COVID, we are going to have to track these patients that have had COVID, have long COVID, over the next 20 to 30 or even more years to see what the impact that is, and recognizing the consequences of COVID and the impact on other disease that people will get over time. You've already heard a lot about APIs and clinical decision support. I think if we can get the resources, if we can get people to define clinical decision support algorithms that will work in multiple settings, and we have a vetting process, if we have a way of clearly indicating the clinical responsibility of these CDSs so they can be used, if we've got the same data, we don't have to worry about translating with some degree of error the data that we are collecting into the APIs and into the CDSs. So the cost of duplication of both data collection, of creating different data models, of multiply treating patients, of having the same patients in clinical research multiple times is something. The one thing that I've been very frustrated about for much of my 60 years that I've been involved in informatics is the fact that we've had to map from one system to the other, and mapping never stops. It's never up to date, and it costs money. It costs the money to create the data elements in the first place, independent, and it also costs money of trying to map these all together. So the movement from paper to digital is having an impact. of bringing those systems together. So one of the things that happens in the US is a project that's sponsored by the CTSA, the NCIS, NSTA, is the National COVID Cohort Collaborative, known as N3C. And in the National COVID Cohort, they're building a database from multiple sites. And I don't know, I think that number now is somewhere in the vicinity of close to 70 different sites are contributing their data into a common database that then is available for research. And the data models that are supported are PCORI, the I2B2 are now under the name of ACT, an OMOP, and a private database from Trinetics. And what's happening is you're mapping from your local database, the local terminology, the local data models that you're using into one of these, and then mapping from here into OMOP. OMOP ultimately is the database. And we have discovered all sorts of problems in the process of doing that. It's the loss of information and inconsistency of the data elements that are collected. The University of California, with their system of COVID, simply said everybody is going to use the same system. And so they used the same data set, and they were able to really communicate, to aggregate the data across all of the universities of California settings. We've heard already about the United States Core Data for Interoperability, USCDI, and I'll talk a little bit more about that. I think HL7 is already making the first steps with the HL7 Odyssey and the OMOP databases. I think you're going to see that move along. But the truth is that that's just the beginning of what I think is extremely important. So what we really need is a common set of data elements. And I would challenge the people that are listening to this from the international community to help us understand the definition of global and how to do that. We need rich attributes, including a data numeric identifier. And the reason I'm arguing for a numeric identifier is the fact that we can send the data to any country in the world and then translate from that number into the language of that country. We ought to make it even better. We need to embed knowledge within the data elements. And I'll give you a little idea of what I'm talking about in a minute. We need to standardize the collection of data. We need to have the same methods. We need the same data elements and the same contents. And we need to recognize that if we can collect data automatically, one, we're going to get better quality and better consistency in doing so. And we need to do research in creating methods of collecting the data itself. To make this be usable for analytics and for research, we have to establish trust, data quality, and consistency of data collection. And we need full provenance. We need to know how, when, and where the data is collected. So I'm proposing that not only do we identify the basic data elements, but we need to enhance the value. And some of this is happening in SIMI, as Chuck and Russ referenced. And then we begin to put those atomic data elements together. We need to have something that expresses blood pressure, very simple, systolic, diastolic, and then heart murmurs, again, with location and other things too. But we need more complex data sets. So an electrocardiogram, for example, or cardiopulmonary exercise testing, two of the groups that I'm working with at Duke. And there are a number of data elements. And if we're trying to look at data coming from different sites, everybody doesn't collect the same data. So again, we need to have that consistency and acceptance of the definition for do so. We need to define structures to capture even more complex phenomena that's easy to work with. And then we could go even beyond that. We can have functional sets such as a well baby workup. We need pediatric growth, kidney function, maternal health, and there are an unlimited number of these things that we can put together. We need phenotypes, diagnostic, treatment, and monitoring. We need to track COVID patients, as I've said. We need registries that are populated automatically with the same data elements that are all the places that are connected in doing it. We need computable model knowledge built into the data element itself. And any defined purpose for standardized group of data elements will add value to it. So phenotypes and biomarkers, we need a standard format for phenotypes. And in my opinion, we need to use artificial intelligence for phenotypes to be able to get weighting factors. If you look at the phenotype for COVID, they're not, all the components are not equal. And nobody says if you've got 2 of these or 3 of these or all 5 of these or whatever it is, whether that increases the certainty with which you're able to make the diagnosis. We need to use AI to create the weighting factor so that if I've got something like a cough and a loss of smell has a lot more weighting than if I have fever. So the effectiveness will require a common set of data elements with a rich set of attributes that are freely available. And the data elements should address all the different kinds of data that we're now collecting: genomic, biomarkers, clinical, environmental, social, economic, geospatial, and any other kind of data that's involved in defining health and healthcare. We need logical representation for expressing algorithms that have to be flexible and have to accommodate the time intervals. And these are the kind of things that Russ talked about itself. So the approach permits and suggests follow-up research projects to define and validate phenotypes and digital biomarkers. We need a newer EHR. I think that the commercial EHRs have done a wonderful time, but they're based on technology that started in the early 70s. And I think our whole philosophy has changed, as well as building the data element. We need to support multiple use of data rather than secondary use. We talk about the primary use of data collection is going to be patient care, and everything else is secondary to that. And I argue that that's an inefficient way and not an economical way of collecting data. We need to support multiple uses of data rather than secondary use. And I'm arguing that the data that's collected should be stored in a single virtual container that I have called the data box. And the data box may have multiple data sets. It may have multiple kinds of file representation, different kinds of maybe relational, it may be non-SQL, whatever, it may be even a flat database, but it all needs to be there. And the interaction with the data box that replaces the EHR is simply providing the REST services: create, read, update, and delete. The data storage is independent of data use, and the user functionality is performed independently by functional apps. And this is a way we can keep up with new technology and new requirements. It allows specialization of data presentation and use, and it enables a competitive market. Supports query-based interactions. We need to pull over push because the volume of data far exceeds the human's ability to be able to analyze it. So the future of data, we need to define every single data element in health and healthcare. FHIR is based on 80-20. The US CDI is a long way, as we've heard Paula comment, of what we actually need. And so I think that we need to define every single data element, and we need a process for doing that, getting the experts. It shouldn't be consensus. It should be driven by the experts. And we need to define the role of AI and machine learning in the use and management of the data itself. We need to get the right tools and functionalities to provide access, trust, accountability, and responsibility. We need to replace this concept of secondary uses of data to multiple use. We need closer ties between randomized clinical trials, observational research, and pragmatic clinical trials. And we can track and control everything related to health from start to finish. So artificial intelligence, I think, is something that's going to change research and also patient care. Knowledge exceeds the ability of humans to use available facts to make decisions. Computers are becoming able to learn from data and the knowledge that's available on the internet and other sources. Computers are becoming self-aware, creating new knowledge. So the driver for new groups entering the HIT market, including Google, Apple, Microsoft, Amazon, and others, are using AI. So the question I ask is not if, but when will computers become smarter than humans? I firmly believe that that is going to happen and not too far in the future. There are some very highly ranked people that are suggesting that this may be as quick as 5 years. But certainly by 10 to 15 years, computers are going to be smarter than humans. And so I ask you, what will be the role of computers versus humans? Will we become defensive, or will we welcome the fact that we now have an added tool to use in healthcare? So artificial intelligence at Duke is using a lot of tools of artificial intelligence, using them defining for social problems. We're including healthcare, antibiotic and cancer resistance, criminal justice, detecting fake news, allocation of public resources to those who need them, environmental sustainability, energy reliability, and political distancing. And I would mention that one of the things that we really are paying a lot of attention to is equity, because in the US, this has become a fairly major problem. And we need to make sure that the algorithms that we are working with deal with equity. And Don Rucker, who was previous ONC, the success of artificial intelligence in healthcare depends on a widespread adoption of open APIs. This depends on what Chuck is talking about, but the artificial intelligence depends entirely on the data is provided. And we need to make sure that we are aware of the bias that may be in some of the data we're providing that results from human behavior and compensate for that. So unless that's recognized and corrected, AI will reflect the bias of humans. So that's a problem we've got to fix itself. So for the future of healthcare, this reflects some of the things that Russ was talking about. So the humans, we've got clinical data, we have social data, we have genomic data, we have behavior data, and all of that is extremely important in determining the quality of life and the length of life of individuals. And there are a lot of increasing number of health analytic apps that are being developed. And we can use these apps to help us understand how to deal with certain kind of disease. We can predict the risk factors, all of those things and do action, but we need to also have a privacy engine that prevents harm to an individual as a result of the invasion of privacy itself. And I think that the cloud itself is going to be the future of really putting a lot of this stuff together. And then visualization, again, that Russ talked about is an important part of that we're talking about. The clinical research will help us because they will help us using training data, and the apps will be able to help create the analytic technique for various resources and the visual analytic techniques that we're talking about. So that was a speed run through. Thank you very much. And we've got some time left for some questions. So I'll turn things back, Philip, to you.
Thank you very much, Ed. That was a great set of presentations, and I'm sure we have lots of questions. So we have some questions already come in. If you haven't yet posted a question or a comment, please feel free to do so in the Q&A section of the Zoom window. Perhaps I could start off with a question to Paula. In your discussion around public health, you mentioned in passing the workforce competencies. Would you like to say a bit more about that? Because most of the stuff we've heard about is pretty technical. So how do you feel that we need to address the gaps in workforce knowledge, training, skills to be able to use all of this data, all of these AI tools that we've been hearing about? If you'd like to stop sharing, Ed, then we can see our panelists. Thank you. So Paula.
Thanks for the question. It's one that we think about quite often. I think there's the question of how do we train people to use these tools, but the flip side of that is how do we train people to use the tools that are commonly used in healthcare that are less and less common in other sectors of the economy. So a good friend of mine, Mark Braunstein, is a professor emeritus at Georgia Tech. And he taught one of the first courses on healthcare interoperability to engineering students. And when he used to teach the CDA-based and V2-based version of that course, he couldn't get anybody to sign up because the opportunity costs of learning those standards that were bespoke to healthcare just didn't really, consider into those, top-tier engineering students. And so when we think about the types of information exchanges that are happening beyond healthcare, there's a significant more supply of people who are well-versed in these API-based ways of exchanging. And so I think that's, one important consideration. The other thing that's going to be important, because it is a bit of a shift, is really thinking through how do we use peer-to-peer learning opportunities? How do we encourage the public health community to be more active and engaged in the global fire community? What I've learned just in my past few years of being part of this is that it's very open and inclusive. And so it's just a matter of stepping into the unknown and then finding people who can help you, work through this. So I think that it's a bit of a overcoming of an inertia. That's always the hardest part at the beginning. But if we make that investment, if we take people who are well versed in these methods and include them in the health departments and other places where workforce is an ongoing challenge, then I think we have a pathway towards sustainable upskilling that will be beneficial, not just within public health or within healthcare, but really broader parts of the global economy.
That's great. Thank you very much. Okay, let's move on to one of the questions that's been posted in the Q&A. Obviously, I appreciate many people are coming to subjects like fire with very little background. So perhaps Russ, you might like to take this question about terminology. Somebody's asked the question, which terminology best integrates with HL7, and by which I assume they mean fire, ICD-11 or SNOMED CT? So how would you address that, Russ?
Well, since we don't yet have ICD-11, that's a difficult question to answer, but my understanding of ICD-11 is it's much more SNOMED-like than its predecessors. So in that respect, I think we may be moving towards the answer to that question being they both work. But in most cases for terminology, you need more than one terminology integrated with whatever standard, HL7 or fire, to address most use cases. And that's something that fire makes easier, because part of the fire specification is a terminology server that allows you to represent data value sets as URLs that are on a server somewhere that multiple applications and organizations can access. I see another question here from Umberto that I would like to address, and that is about COVID-19 accelerating interoperability. I think COVID-19 has accelerated innovation, at least. Whether we've really developed new interoperability is a different question. But on Friday, there was a press release from Greater Houston Health Connect, which is the health information exchange in the eastern part of Texas. I think it represents something over 10 million individuals in that area. They published a press release that they have a COVID-19 cohort of 1 million individuals that they have identified. And they also therefore have the longitudinal record of those 1 million individuals. So not only do they know that those 1 million people have a positive COVID-19 test, they know something about the conditions that those individuals have, and they have data from multiple EHRs about those individuals. So the potential to do population level analytics on that 1 million cohort of COVID-19 patients is incredible, and is a great demonstration of the interoperability that is going to be possible. And to use FHIR to access the data of those individuals will no doubt produce great insights.
That's great. Thank you very much, Russ. Interesting question just come in from Bill Hirsch, which will need a bit of contextual explanation for those that are not familiar with the field. The question is, will fire solve the curly braces problem? Which I think is in reference to the Arden syntax and the way that the medical logic modules worked in that standard. Would anyone like to comment on that question?
So I'll respond to first. The curly braces problem is related to that diagram I showed, that different EHRs have different ways of representing the same data. And the curly braces problem is exactly that it was difficult to use data from different EHRs in the same decision support because it didn't look the same coming from a different EHR. So yes, but I would offer the caution that FHIR doesn't solve the problem, but using FHIR profiles that express a model for the data that you need in whatever decision support does solve the problem. If all those EHRs use the same profile for the same data, and that in fact is what the new US regulations that are going into effect now for the FHIR APIs specify, that there is a set of FHIR profiles called the US core FHIR profiles that for a large a set of important data say that each EHR must represent the same data in the same way using the same FHIR profile. That will solve the curly braces problem.
So this is it. I mean, that was what my whole talk was about that. And I have to confess that having multiple terminologies doesn't help us have true interoperability because there are too many ways of saying the same thing in the controlled vocabularies that exist. And I'm not saying that you throw everything away because there's a huge amount of intellectual content in those. But if we adopt the same data element, if we collect the data element in the terms that the clinicians use when they're talking to each other, should be the way that it's expressed. But I'm arguing that the name of what you call something is only one component of all that you need within that. One of the problems that N3C has is the differences in units that were not included in some of the transmission of the data. Some temperatures were collected in Fahrenheit and some in centigrade. There are places where you couldn't tell the difference. And so I really think we have to go back to the very basics of creating the data elements, use the intellectual content coming from the different control vocabularies and others, but adopt that one system and use it in the storage, in the EHRs, if you will, use it in the conversation, use it in the analytics, use it in the decision support algorithms, and you can move it from place to place. Because if you pick the wrong elements, you may get the wrong answers. And so it does have the potential to solve, but only if we go to a degree of consistency and we use the same data elements with the exact precise meanings.
Otherwise,
Bill, I have another answer for Bill Hirsch, because I think this is a really critical question. I think Russ has described it perfectly. The issue always is that every programming language has a curly brace problem because we don't mean the same thing even amongst people who understand the language. It's not simply the clarity of the terms, but what's routinely called semantic drift. The same words don't always mean the same thing. And we will constantly be trapped into it. I think the FHIR profile solution solves many of those problems, but it will always fall short of complete interoperability. Sorry, Bill.
Oh, thank you very much. So let me move to a different question. This actually came up in our panel yesterday with when we were talking about maternal and child health in low and middle income countries. And in his presentation, Alain Lebric from Johns Hopkins was talking about fire potentially offering a kind of a leapfrog opportunity for developing countries, rather in the same way in which developing countries went straight to mobile phones rather than worrying about wired technology as we did in Europe and North America, that potentially they can go straight to fire as a basic interoperability standard out of the box, rather than worrying about all the intermediate things that we've been through in the Western world. Would anyone like to comment on the utility and applicability of fire for developing countries?
I'll go ahead.
Ed. Go ahead, Ed.
No, go ahead. I'll follow you.
We have reached out to those countries for whom this will have the greatest impact. Clearly, the adoption of expensive, complex electronic health record systems is not a solution either in the near term or moving forward. Fire will certainly provide capabilities for data interoperability. There will still need to be solutions and platforms developed to make that technology a reliable means of exchanging data in a comprehensive longitudinal fashion.
Thanks, Chuck. And Ed?
Yeah, I was quickly. The interesting part about it is you don't have to go to the low income countries to really see this problem. It happens in the US all the time. We're working with disparity groups now, and the language they use, the requirements they use, the way they think about health is totally different than it is in the middle class and upper class. And I think what everybody thinks that we all think fire solves every problem in the world. We think it is a key part of it. And we think that we need more and more people to help us understand the user side of this. How do we match it to the requirement? And it takes more than fire. We build it around fire, but part of that is really dealing with the disparities, the equities of the healthcare system, and clearly, I think the analytics. If we had that database, I opened up with my first slide. If we had that database, we could really understand better with the analytics what countries have and what countries don't have. And it will give us a much better idea of where we need to put the emphasis of improving the health of the people of those countries. But it needs to, I was working with the Caribbean, and the question I asked was, can you tell me the top 3 problems in your country from a health perspective? And looking to see where you're spending the money. The point that I want to make is there's enough money in the systems already if we use it properly. And we need to start picking other problems that are costing us so much money and fixing those, but we need to fix it with boldness. I hope every single organization, including EMEA, will take a theme of be bold for next year, because you've got to go, you can't fix it with today's solutions. You absolutely have to think of the future.
Thank you very much, Ed. I think that's a very good way to bring our session to a close, as we're slightly over time, I'm afraid.
Yeah.
So I'd like to thank you all very much. I think it was an excellent panel. We could go on for many, many hours because this is such a fundamental topic in health informatics, and I'm sure we'll revisit it in future events. So thank you very much, each of you, for your contributions.
Thank you, Philip. Thank you.
Thanks. So if I could just remind everyone that our next session tomorrow starts at 2 p.m. UTC. We have the Best Paper Award, and then we have a panel session very closely related to our conference theme, One Digital Health, which is based around a new working group that's been formed in EFME. So thank you very much, everyone, for your attendance and participation today. And we look forward to seeing everyone participating again with our session tomorrow. So thank you. Good night, good morning, whatever it is, wherever you are, and see you again soon. Thank you.
Thank you.